a techie, actually a former colleague of mine, Bank of America, working on platform Quartz. He has engineer, developer, tech lead, CTO. Definitely look for his talk. We'll have a Q&A, so raise your hand. Question. Start.
Thanks everyone for coming along. Get the picture up, please. Thanks. So normally I like to actually use a clicker because I walk around shadow up quite a lot, and B, I've lost got about 100 in my house, like socks. Yeah, so guys, if I'm wandering around a little bit. So I'm going to be talking about Uncomfortably Simple, and what that means, a framework for builders to tighten the feedback loop. Just to give a very, very quick sort of background on myself, I've been developing code for Okay, I'll try and keep my corner. So yeah, I've been developing code now for 32 years, and I started young, and I absolutely love it. I love everything about technology. That said, my views on how things should be done have changed a lot. I started off in a huge enterprise at Merrill Lynch, then Bank of America, did a couple of startups, did okay with them, but not very well. Learned a lot of lessons. Your first startup is always hard. Joined Amazon for a while, where I learned a lot, which will be somewhat of what I'm talking about here. Then joined a small startup called SingLife, where as CTO, that's now a $4 billion company. So seeing that go from 20 people to what it is now was quite a journey, which impacts a lot of my thinking. That got too big, so I quit. I like smaller stuff, and I now work with Mission Plus, where I help people build cool products using primarily offshore development. All right, so let's get into this. Right, we talk about keep it simple, stupid, you ain't gonna need it. We talk about that kind of thing all the time. We all are familiar with this concept. It's nothing new. My assertion is, however, that we have this comfortably simple view where we think that we're being simple and we think that we're not prematurely optimizing, but actually oftentimes we are. And actually simplicity is not a simple thing. Let me give some, oh, man has a clicker, but all right. This is only going to make me walk around more now. Okay. All right, thank you. So let me talk about what I actually mean when I say that we are comfortably simple. We come up with a whole bunch of reasons to manufacture complication. I'll give some examples up here at the top. It won't scale, okay? Well, you don't have any users yet. Why are you caring about scaling? This, by the way, I'm talking here for a new product. That might mean a startup, but it might mean a giant enterprise that is launching something new. Okay, so this is maybe startup focused, but applies to a lot of other things. People need more features. They won't use my product without more features. Have you actually asked them that? Do you actually know that is true? Or is it just your assertion or your perception, hypothesis for why people aren't buying your product? Next one, I love this one. It won't pass an audit. I guarantee you that unless you're getting something which is going to be injected into humans, you will never get audited if you never launch. You will never get audited if you have no users. I can pretty much put money on that one. People won't pay for something this simple. Now that might actually be true. Yeah, maybe they won't, but they'll probably give you some feedback on it. Yeah. So instead of waiting until it's more complex, then getting feedback, launch, get feedback, and work out your charging model afterwards. we need flexibility for the future. This one is probably the most pernicious one, I think. This is where people start building crazy microservice patterns so that in the future they can replace the database. That you don't have any users, you don't have any product, you haven't got any revenue, and how often do you actually change the database? Calm down. So I love Gall's law that says anything which is complex and works evolved from something that was simple and worked. And I feel that part of the reason why big migrations, for example, often fail is we go from one thing which is super complex, has evolved over years, has requirements baked into the code, and we try and jump straight into a second system with equal complexity, but one that hasn't iterated up into that place. Typically, that then means that you find out all of the actual complexity requirements during UAT, which goes on forever, and you never really actually go live. And I believe that the essential complexity of systems has to be born iterative simplicity. So let's look at some specific ways for how we can actually do this. What does this actually mean? Now, the build versus buy conversation has been one that's been going on for a very long time, obviously. 10, 15 years ago, I probably erred towards build, not because I've changed, but I think the ecosystem itself has changed. And when you had closed products that couldn't really interact with one another, in order to get the level of flexibility you needed, oftentimes that meant building something. Today, that is simply not true, right? When you buy products, often they're very configurable, but most importantly, they're API driven. And so there's all sorts of stuff that you can do to put wrappers around it. You can connect it to things. You can, change fundamentals without having to, throw away the product and choose something else. Now, that said, in most cases, actually, the correct case is probably assemble. Now, whether that is assembling multiple bought products or whether it's using some kind of open source framework or something like that, I feel like assemble has kind of solved the build versus buy product discussion. There's a really nice chart that a guy called Joe Lonsdale uses. And he talks about what is possible versus what's actually done. And so the line of possibility gets up like this. The line of what's actually done goes like this. And his belief is that when those two lines get too far apart, they snap, and whoever's still on the bottom line dies, goes out of business, dies. So, for example, steam engine, for example, electricity, computer. But if you don't adopt what is possible and you continue to use what is sort of the status quo, break. I believe that that top curve can be pretty accurately reflected into most popular open source frameworks. Not perfect, but it's a good metaphor. Whenever companies set up innovation labs to do fundamental R&D, I ask myself why. What is it that's so innovative about what you're trying to do that isn't just trying to take state of the art and actually incorporate it into your business, rather than trying to innovate something that is totally new, but probably is unnecessary. Now, my favorite approach to reducing complexity around prototyping. This is something which I wish I'd learned earlier, because I look back on some of the previous things that I've done, and I could have saved myself a lot of money, or the bank I was working for a lot of money, if I'd done a lot more prototyping. First thing, though, we need to be very clear on is what is an actual prototype? What am I actually talking about here? I love when I go and talk to people and I say, okay, you do prototypes, you do experiments. How often do they fail? And the person says, oh, I'm so good at prototyping, they never fail. And I say, well, then you're not actually experimenting with anything. All you're doing, taking something that you think is already true and building it out. Prototypes and experiments should fail some of the time. That it means it's a good experiment. The second piece on that is that a prototype is not version 1 of the software. What you're building is not necessarily the first version that's then going to be built on in the future. The technical choices you make, the way you approach security, the way you approach all sorts of stuff is very different in a prototype versus something you're actually building. You should be assuming you are going to throw it away, and you should get it out as fast as possible. If that means using just Figma, then that's fine. If that means using a low no-code platform like Bubble, that's fine. get it out as fast as possible so people can actually give you feedback. The other thing on the prototyping is make sure you're prototyping the right thing. Let me give you a use case or an example from the real world. I was asked to build a prototype for a community that wanted to discuss a particular topic. And they were super excited about this idea that the onboarding journey was so cool and pulled in data from LinkedIn in such a cool way that it would then so fast get into the system, and it would also categorize what your personal preferences were and connect you to the right people. And I said, I can prototype that for you for sure, but what does that prove? Because I promise you I can build you a sexy onboarding journey. I promise you I can connect you to LinkedIn and pull in data. What I can't guarantee you is that anyone will want to use the platform after they've onboarded it. What is the purpose of the platform? Why would people be part of this community? Not because of the sexy onboarding. So you can fake that entire piece and just build the stuff which is ambiguous or you don't have confidence around. Person refused my advice. We built a nice prototype. We actually built part of the actual product and no one used it. The LinkedIn auto categorization stuff worked fine. No one wanted to. Yeah? And I wish that we prototyped the actual, not just some sexy, happy. Hands up if you know what that is. The Mona Lisa. Yes. Using 8-bit colors and a very rough pixel size. This scope is probably the area where the word uncomfortable I'm most sort of pushing towards. People often feel like when they're trying to build something that it's not ready yet. They show it to them. And they get very uncomfortable, and so they start trying to be more polished, add more features, so that when they demo it to people, they can say, hey, look at this, this is awesome. Problem is, maybe you've built too much. Now, you all recognize that as Mona Lisa immediately. If I had gone and drawn the top left corner in perfect detail, but only that little quarter and said, what is this picture? You would have said, I have no idea. I could have probably done the entire top row and you still wouldn't have any idea. I could probably have done 2 or 3 slices and you still wouldn't have any idea. And so the point being, build the absolute simplest thing that is end-to-end first, and then iterate on top of it, even if it means it's ridiculously simple. Give an example from ThingLife. When we created our mobile app, we had to connect it up through quite a complicated middleware system and issue insurance policies off the back end. Now, I connected it up so that when you bought your policy popped out in the other system and said, hello, Ned. That's all it did. And the message that went through was ridiculously, basically said hello. And I remember demoing that to someone, and someone was like, well, that's not an insurance policy. Is it a term life policy? Is it a 30-year term, whole life? Is it universal life? Because the person was focused on the feature set of the insurance policy, insurance role. But the speed with which I could iterate that end-to-end flow until it did have actual policies being generated was much faster versus building a perfect insurance platform, a perfect mobile, trying to connect them together and realizing that, well, actually, microservices are the bane of most people's existence. Most companies are not big enough to do this properly. We like to do it. We were told to do it for the longest time. I got very excited by it. People have obviously switched that now. Everyone's talking about modular monoliths, self-contained systems. But the guidance I would give around this is, sure, split your logic up. Have services. It's important to have services. But make those services roughly the same size structure. So if you have one dev team, one product team, build one monolith, one service. Yeah? A lot of people hate hearing that. They say, oh, but what if I need to, oh, but what if I need to scale independently? So you've got real users, don't worry about it. Yeah, get something out and iterate instead of being focused on how you design your service infrastructure. As you get bigger, you can solve that problem. I like to relate this a little bit to Conway's law, that any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. Kind of reverse engineer that and say, well, okay, if this is my communication structure, then let's create code that looks like it. Let's not have one team checking code 10 different databases before you've even launched the product. So this one has most words on it. This is because my lawyer reviewed this slide because they were very worried about what I was going to say, and that is true. Compliance. I've spent my entire career working in financial services or with financial services. I understand this is a thorny problem. I am not going to say it's simple, and obviously culture and people are as important here as anything else. But if you do not have clients, or worse, you don't have a company because you ran out of money, you probably don't have much risk. So trying to front load a load of compliance stuff is a waste of time if you never actually get off the ground, to the point before about being audited. I would say that from my experience in talking to regulators and auditors, areas where that's perhaps got to be the most careful is the data residency, data hygiene around customer data. Don't lose customer data, ever. And second, don't accept money or send money to the bad guy. Yeah. Almost everything else, I think, in most tech regulation, kind of regulators are more flexible than people make out. External auditors are more flexible than people make out. You will typically have more issues with internal audit than you will with external audit in terms of scrutiny. So dial it down until you really have the use case to support it. Risk balance. Performance testing. Again, uncomfortable, not comfortable simplicity. We all say, oh, we're not going to prematurely optimize, when we prematurely optimize. Yeah. I had an example, right? We have a joke. There's only two difficult in science: naming variables, cache invalidation. I had a project I was working on where someone had added a cache for scale on the database. They didn't have any use. During a demo to probably the only client who was close to buying the product, they had a caching issue that meant that the way that they were expecting it, and they lost the ultimately. Now, if the products you're buying have built-in caching and it all works perfectly, great. But if you're trying to build something else, don't add this complexity up front until you've actually got the traction going. And what I find also very interesting is we've all had performance issues. They're always in things that we didn't expect to be the problem. They were probably some of the coolest evenings we've ever had, right? 3 o'clock in the morning, get that server up before the other one sets on fire. There's so many cool stories in the trenches we have with our colleagues around this problem. So even when it does go wrong, we typically. So if everything is about simplicity, well, where do you invest your time? And I'm stealing Elon Musk's, well, it's from an interview that I watched with Elon Musk, and I've tried in vain to find it since because I'd love to use it in some. But he said he's building 2 products, not one, at SpaceX. The launch pad that he launches rockets from, and the rocket itself. And he has 2 completely separate teams. They operate in 2 completely different ways. The main point being, the launch pad has to be super repeatable. You can put a new rocket on, you can launch it off, get another rocket up on there, launch it off as fast as possible. That thing needs to be stable. It cannot fall over. You can't have to rebuild the launch platform every time you want to build a new rocket. That was how NASA had done it. Every different rocket design had a dedicated launch pad, which meant that the cost of building that was very expensive. So he said, there's 2 products I'm building here. And I love that analogy, and I've kind of brought it into this whole uncomfortably simple idea, is that there is a whole bunch of stuff that is worth investing in a little bit if it means you fire off more rockets. Yeah? So uncomfortably simple, overly simple on your rockets, but your launch pad as repeatable as possible. So you iterate. Do 20 releases a day, that's a great thing. More people, yeah, iterate. So the automated testing, the ICT, infrastructure as code, all that good stuff, right, is worth putting in if it means you can launch more rockets. But I thought you said don't build anything too complex. Infrastructure as code, ooh, that's a little bit complex. Unit testing, a little bit complex. A few things. Buy, don't build. Yeah, a lot of this stuff, there's great suites out there that you can just buy, right? People who are self-assembling their launch pads, well, assembling is fine, but trying to build themselves are wasting a lot of time. Secondly, prototype as much as possible. Don't put that onto your launch pad, right? That's your simulation of your rocket before you even build it, yeah? A lot of the good frameworks already have existing tests, so when you're evaluating open source frameworks or evaluating some library to bring in, if it's got the tests already, you can hook into pipelines, then you're in a winning state already. The last two are slightly different in nature. You might think that investing time on the launch pad is a waste of time, but actually, human error will slow you down because you're setting up your production environment, you're setting up your staging environment, you're setting up your environments for developers. If you don't have that automated already, then you'll probably slow yourself down in messing things up, having environment mismatches. And then finally, and this is a super important one, compliance becomes easier, to the point before about simplified compliance. When you've got all of this stuff automated, then you don't have developers with production access, all of that kind of good stuff. And so then talking to compliance people and automated compliance becomes a lot easier. So hopefully, everyone, if you can take away only one thing, all the rest of it was stuff that you've probably heard, but you just have to reinforce, but maybe the message around the launch pad versus the rocket. Make that rocket super simple, make your launch pad super stable. With that, thank you very much.
And do we have questions in the audience? Thank you very much, Ned. Your hand.
No, oh, you're yawning. Give me one of these ones.
Great.
If anything comes up, you can email me here. You can look on my blog where this is actually an adaptation of a much longer blog piece. Fine. All right.
Thank you.
Thank you.